All right, everybody, it's 1 minute past the hour. Welcome, everybody. My name is Kamesh Pemaraju here at Platform 9. I'd like to welcome you all for this special webinar on networking and Kubernetes in the world of 5G. So we will be talking about the steps in the journey. So the series, as you all know, if you're coming in for the first time, is about the journey to production with Kubernetes. And there are several use cases associated with that. And today, and we've been covering a number of these use cases as during the series. Today, specifically, we'll be covering 5G and networking. If you can go to the next slide, Peter. So in today's webinar, we'll do a kickoff and introductions and the usual Q&A reminder. Peter, as you know, has been talking about the journey to Kubernetes in the series. We'll do a very quick recap of what customers are going through as they get Kubernetes into production. What does that journey look like? What are the steps in that process? What are some of the challenges? Right after that, we will jump into a fireside chat on the specific networking considerations with 5G and Kubernetes. And for that, we have today Rupak, who is our CTO and co-founder at Platform9, who is very deeply involved with a lot of implementations in this area. And we'll cover 5G and NFV and Kubernetes and all the different components of it, and then we'll end up with Q&A. So as usual, you can use the chat window or the Q&A button at the bottom of your Zoom screen to ask questions anytime along the way. We'll try and answer them if it makes sense to answer immediately, or we'll answer them towards the end of the webinar here. Peter, next slide. And as we have a special drawing and giveaway, we do this for every webinar. For those who want to learn Kubernetes in depth, we have partnered with our learning partner, Learn K8s. And we will do a random drawing at the end of the webinar, and we will give one free online Kubernetes course to that lucky winner. And there's a giveaway for every session. So we would love you to join us in every session and take advantage of this offer, and of course learn about all the use cases and the journey to Kubernetes. Next slide. So let's do a quick introduction. Peter, as I said, is our chief technologist, and Rupak is our co-founder and CTO here at Platform9. I'll let Peter and Rupak introduce themselves and then turn it over to Peter to start the journey slides.
Great.
Thank you very much. Yeah, go ahead.
Hi, everybody. My name is Peter Frey. I'm field CTO here at Platform9 Systems. I do lead our pre-sales and our post-sales customer success teams. I've been with Platform9 for just about 3 years, almost exactly right now. And I'm presenting to you today from sunny Florida, which is not so sunny. I'm on the West Coast and there's a hurricane coming. So if I suddenly vanish, probably because I've lost power or something like that. But anyway, I'm looking forward to our talk today about Kubernetes and 5G and some of the technical details around how we can implement that. Rupak?
Thanks, Peter. Hi, folks. My name is Rupak Parekh. I'm one of the founders as well as CTO at Platform9. I'm deeply entrenched into, obviously, the technology at Platform9, and specifically working with some of the partners that we have in the 5G arena and working with Kubernetes. Looking forward to this conversation.
Great. All right, I'll jump into a quick review. This whole series of webinars, there's 8 webinars that we have here. They are about the journey to Kubernetes in production, right? Each step of the journey to Kubernetes, in my mind, our customers and our prospects are making decisions, and I talk to our customers a lot. And so I'm just going to review that really quickly to give you an idea of where we're at in the journey and where we are at in the webinar series that matches sort of this journey. That was the goal, right? So when I talk to people, right, there is always a set of people that are in every organization and in every enterprise that are looking at Kubernetes and how will Kubernetes either help or not help our organization, right? So those might be enterprise architects, they might be developers, they might be somebody in the office of the CTO, but people are evaluating Kubernetes. And they usually go down the path of, well, let's try Kubernetes. Let's see what it means. What does it mean for our company? So then they say, do I want to deploy this on cloud? Do I want to do it on-prem? Do I want to use VMs? Do I want to use bare metal? And in the case of today, they're making decisions about the CNI as well. Which networking interface do I want to deploy with Kubernetes to do this? And then when they're done with that, right, they deploy their first app, and that's usually a hello world kind of application. I deployed Nginx as my first one. And then they do something more complicated, WordPress, you know, and this is only slightly more complicated. They Google how to do it. They're doing research. They find the Helm chart, but this requires persistent storage, and it sometimes stumbles people a little bit. Then they have to Google around and say, how do I do persistent storage in Kubernetes, and how do I solve that problem? And we'll get to that in one of the next webinars in the series. But right today, we're at this kind of first box, and we're going to talk about different CNIs that you can implement to, I just had a brownout. You know, refer to the networking layer for 5G, okay? After we get WordPress, these enterprises are typically looking for some sort of tier D application to deploy in Kubernetes, right? In the case of 5G, it's probably going to be NFVs. That is not a tier D, but they're trying to figure out how to do it. How do I deploy it? How do I install it? And we're going to talk about a lot of that today, Rupak and I. And then once they get the apps kind of deployed, they're pretty excited, but then they realize there's a whole bunch around day two operations. How do I monitor the application, the network function, or how do I monitor Kubernetes, and how does one impact the other, right? And so they start Googling around on how do I do that. And they find that there's things that they can pay for, like Datadog or Prometheus and Grafana, which is kind of seeming, you know, the industry standard for monitoring in a Kubernetes cluster. And then they Google around, how do I deploy that? And they deploy said applications to get that up. And then the same sort of story happens with logging. Which logging construct do I want to use? How do I want to deploy it? I need to capture events and logs from my pods. How do I do that in a Kubernetes world, in a 5G world? You know, very important as well. And, you know, then they start thinking about, okay, now I've got my app, I've got monitoring in place, I've got logging in place. How do I repeatedly deploy this? Do I want to use something like CI/CD or a Jenkins X? Do I want to use something like a Spinnaker? They Google around on how to do that. Usually what we find out is most organizations have a tool in place. It might be just regular Jenkins, and they try to adopt that to fit the Kubernetes world, and that's usually just fine. Then we start talking about A/B deployments and service meshes. A lot of our customers, they skip this step. They just want to get their app up and running, and then they'll look at how do I do A/B deployments later, right? As they're finding out, is Kubernetes is not just a simple tool. It's a tool, but it's also an ecosystem. And then there's things like Prometheus and Grafana and Alert Manager and Istio and Linkerd and all these other things that can go into this Kubernetes cluster. And they have this goal of getting some things running and trying to figure it out. So they come back to it. Then at some point, information security gets involved. They do things like identity management. You know, how are we going to identify who can start and stop pods, delete pods in a production environment? Do we have PCI compliance? Do I have red and green zones defined? Is my data at rest, data encryption kind of happening in, you know, data at rest, data in flight? Is it all working the way we want it to? And properly partitioned and network segmented and all that kind of stuff back to the CNI there. And we eventually get off that, and they're starting to think that they're ready for deploying the Kubernetes and running it in production a little bit. And then they start thinking about day two operations. What happens when I need to upgrade Kubernetes? Do I have to upgrade each of my CNIs, right? Do I have to upgrade a Multis? Do I have to upgrade SRIOV if we're doing line speed stuff? How do I do that? You know, just causing Kubernetes 117 to 118, what happens to all these other things that I have to do? Will they still work? Right? What happens if etcd loses quorum in a Kubernetes cluster? What happens if a worker node gets a disk full? There's all kinds of things that happen in day two that, you know, need to be considered, and that's when the SREs and the DevOps teams are really starting to get involved, right? And we'll get to that in our webinar series as well, right? And then, you know, are we ready? Have we lived through a production outage? How are we going to handle production outages? Things like that. So that's kind of the journey, right, that most of the enterprises that I'm seeing today are taking to get to adopt Kubernetes. And they're seeing a lot of benefits to Kubernetes. That's a whole other webinar series we can talk about. But most of our organizations, they're looking for something that's simple. I want to be able to deploy Kubernetes fast. I'd love to have out-of-the-box monitoring, out-of-the-box logging when I deploy my Kubernetes clusters, a simple decision for me to select to see a storage interface, right? If I'm deploying an AWS, do I want to use IO2 or GP2 or different kinds of block storage that are available? I want to be able to just click and say, I want Calico. Maybe I want Calico plus SRIOV and DPTK. We're going to talk more about those later today. And then, I'd really like an instruction manual on how to figure out how to do CI/CD in my organization. So this is a little bit of a Platform9 story, right? We do offer a solution that covers all of these things. We do have world-class support, 17 or 18 certified Kubernetes administrators on staff and SLAs to back it up as well. And if you want to learn more, we'll talk more about that at a later time. So as it relates to the webinar series, there are 8 webinars in our series. We had the intro on September 16th. We did networking 1, which is a kind of a high level Calico environments. And we talked about what that means and how you deploy it and that sort of stuff. And today it's myself and Rupak. We're going to talk about our experiences with helping our customers in the 5G world, right? And what kind of considerations do you need to take when you're doing that? Then we're going to get into storage and loggings and DevOps and pipelines and day 2 operations. And then we'll finally wrap it up in April of next year. We're doing one of these a month until they're done with a panel where we will have members from each one of these webinars all on a panel where we can have an interactive kind of conversation about it. So it's an exciting webinar series, and I hope people will join as we move forward. And that moves us into the topic for today. So we're here to talk about Kubernetes and 5G and how that's what's happening in the industry. So Rupak, I guess I toss my first question out to you, right? What do you think, right? The industry with 5G or 4G, as it's been evolving, has really been changing. What are you seeing happening in the industry out there?
Yeah, so Peter, great question. So if you look at the history of networking, especially the wireless network, they obviously evolved for for a long time. It was just voice, and then we got data thanks to iPhone and Androids of the world. Moved into 2G, 3G, now 4G, and now obviously 5G is coming up. And so that's great from a consumer perspective, but the underlying technology that powers this is also changing and is actually becoming more and more flexible. So for a long time, if you look at the telcos of the world, as well as the providers of the software, they were actually shipping these custom physical boxes that you will take and install it in various locations. So it would be close to your cell phone tower, which still happens. Also at other aggregate locations in your core data center, so on and so forth. And when you do that, and let's say you want to upgrade them or go to the next version, it becomes more and more difficult, as we know. And the world has slowly moved into everything being software. And what has happened in last few years, I would say, but in last 4 or 5 years, and is that instead of having those boxes, those are just what they call as COTS, just off-the-shelf servers. So you take the off-the-shelf servers, then you deploy the software that does the packet processing. Remember, nowadays, when you make a phone call, in most of the time, not all the time, when you make a phone call, it's actually going through IP. So a lot of those processing is done in the server class machine, x86 server class machine that does your packet processing. And the components in those servers are not just processes, but they are actually virtual machines running on those boxes. And these virtual machines are highly performance, are tuned to run on those machines, and they are tuned to make sure there is no jitter, the latency is low, so on and so forth. So that's how the world was working for last few years. Now there's another wave coming. Now, instead of having virtual machines as the building blocks, which already gave a lot of flexibility to the providers, they are moving into containers. They want to divide up their application into smaller pieces and run it on this physical machine. And containers is pretty interesting. Virtual machine, depending upon whom you talk and what kind of optimization that you have done, it gives you isolation, so it's great for security, but there is an element of some kind of performance hits, and depending upon the tuning and the things that you have done, it can be maybe negligible to up to 20%. And that's where containers are even more interesting because you are directly running it as a processes, but isolated among other processes. So that's how the industry is evolving, and we are seeing a shift specifically with 5G, where more and more companies are actually talking about the service architecture, where, believe it or not, they want to take these edge location where 5G will be deployed as another cloud, where their applications that they've written, they're all containerized, just like the way they deploy into cloud, they can deploy it into this remote location. So that's a huge change that's happening. Obviously, it has been happening and evolving. It's not going to happen overnight, but that's a huge change that we are seeing in the industry now. Peter, you're on mute.
Yep, got it. So we're trending to moving from physical to virtual, and then ultimately into the containerized world, which is I think why Kubernetes is becoming such a big play with within the telcos.
Yep, and as we all know, Kubernetes is becoming the default orchestration system for containers, and it has been for now, I would say, last 2 to 3 years now. There were others in the mix, but Kubernetes has emerged as a leader. It's becoming the de facto standards, and everyone is adopting it now.
So Rupak, let's talk about some what are people doing with 5G? What does it mean? Why NFV in the real world? And I'll start.
Sure.
There's a lot of stuff going on in the connected car world, right? I think there's a big push by the automakers. I've got some personal experience with some of them. They want to make everything that they do safer, right? So sort of think about it in this kind of terms, right? The manufacturer I worked with was Volvo. If there's a whole fleet of cars driving in a particular area, and one of them hits black ice and skids, they want to take that information and share it in real time to all the other cars within a certain vicinity of that car. So if they're coming up to that environment, they can be aware in real time. So that's, I think, something that's kind of critical for safety in cars, right? I see 5G increasing, drastically, 20%, 15% in 2020, 75% in 2023, 95% in, I think, 2025 was the stats I was reading, right? Low latency, it's got to be able to get that data from one vehicle out and back into the other vehicles extremely fast. In most cases, in the 4G world, that they were targeting 50 milliseconds. I think with the 5G world, we're going to hit a much lower latency. So that's going to really enable that. In effect, what you're going to see is your car, right, is going to be a multi-sensor IoT device. It's going to sense, the local environment, the black ice scenario, right? It's going to crashes and road conditions. It's also going to, maybe have cameras in there looking at the driver to see if he's dozing off. All of this kind of information is being shared in real time outside of the vehicle, and 5G is really, enabling that.
The example that you gave, Peter, is kind of a prime example of where 5G and the fact that 5G is going to provide low latency connections to these end devices, and car being one of them, is really the use case. But let me also talk about some of the other things that we don't really think about. Enterprises, specifically the big box stores, and even others where there are factories. And today, if you look at them, let's say there is a robotic arm, or there are many robotic arms creating, let's say, a car. Okay. And if you look at those factories, they are connected via cables to some central location inside the factory, which is controlling all those arms. But what's happening with 5G is a lot of these companies are looking at 5G as a solution to cut those cables and make it more efficient. So now you will have all these automation systems inside the companies, inside these factories, which are really using 5G as the network instead of your wired network. So really replacing that network with wireless networking, which is high latency and very low latency and high bandwidth. Uh, Similarly, if you look at big box stores and warehouses for Amazon or Target or Walmarts of the world, where you have these vehicles which go around the floor, capture or get items and get to other locations in those stores, those all need to be connected. And obviously you cannot have wires hanging around them, uh, and they're making some decisions. So they will be connecting to 5G. And if this all looks fancy and futuristic, it's not actually. There are companies who are already trying it. Now, some of this is not in production, but there are companies who are trying it, and people are moving towards that. A very similar kind of use case is in, which is probably even bigger than the smart factory, is video surveillance. We know how important security is, and for years we had these security cameras around the premises. They're all connected uh, to some, again, central location where it will be recorded, so on and so forth. Yet again, the cutting of the cables using 5G to kind of make that infrastructure possible. Not only that, but also because they can now, these cameras can now feed into into a central location in that enterprise or that location. They may have AI-driven detection and say, oh, this is not a person who is climbing over the wall, but it's just a bird flying close to the wall. So those kind of use cases are becoming possible with 5G. Yet again, the important point here is it's not just telcos who who will benefit from that, but also enterprises who will benefit from 5G.
You know, as we were talking, Rupak, I started thinking about it. It's not just the low latency that's the requirement, right? You know, I was thinking about your car will become the next mobile multi-sensor IoT device. It's the amount of
Yep.
data that's also being transferred. Bandwidth is absolutely critical.
Yep.
And that's going to be growing exponentially from every device that's connected out there on a 5G network.
I think there's a relevant question right now. I think that might be worth looking at. So the question is about, are there any real customer use cases that are using Kubernetes with 5G in production, or any examples of that?
Rupak, you want to take that one?
Yeah, absolutely. The short answer is absolutely yes. We are working with a partner who supplies 5G software to their customers, whose whole stack is built on Kubernetes itself. So yes, and we are piloting with bunch of end customers who are using that.
I think I'd add to that, right? You know, from my perspective, I help our customers in the purchasing journey, and they last year, maybe a year and a half ago, everything was on virtual machines. And how do I deploy virtual network functions on top of a virtual machine? And that was the standard. Everybody was doing it. I probably did 4 different proof of concepts in that environment. And now everybody's POC the same kind of network functions, but they're all running in containers. Even the year and a half ago, they were telling us that the plan is to go to Kubernetes, and they are actually going there now. So I see that adoption actually happening. Okay, so maybe we should talk about, you know, what does it look like? You know, when a telco deploys an NFV architecture, it's pretty complicated. Rupak, you want to talk through what that looks like?
Yeah. So this is a pretty canonical example of a deployment that I'm pretty sure all of you are familiar with, but this is just a revision of what it looks like. When you're talking about an end-to-end 5G deployment with all the components, and there are many, many components. Some can be deployed independently, some may not be able to deploy independently. So you will have from left hand side where you have devices. Peter spoke about connected cars. Your phones obviously are making calls. Um, then you have the radio towers where the signal lands, and maybe at the radio tower or close to radio towers, it will convert into IP packets. And there would be devices which are controlling some of those radio antennas and stuff like that, really part of what they call as RAN. And once you get that packet, it goes up to your aggregation or your co-locations where, or your regional data centers, depending upon the customer and partner that we talk to, they're different. And from aggregate edge to core data center. So the core data center is where in most of the times the brain lives, and a lot of the billing and some of the other enterprise systems also lives. There's another component. Some of these core data center components can actually sometimes run in clouds as well. So we are seeing this massive distributed architecture, specifically with the telcos, where they have things running in far edge location, in near edge, core data center, and cloud, and a mix of all of them, all working together. And then they have their operations teams really working to make sure the service availability in all of these locations. So that's really the high level picture of what the deployment looks like. But how do you realize it? What does it actually mean when you throw Kubernetes in that? Peter, let's go to the next slide, and then I can show you how does it translate. This whole deployment translates into that. Go ahead.
I just want to give an impression of the scale of this, right? You have this access edge. Think of that as cell phone towers, and they are everywhere across the country, right, Rupak? The aggregate edge,
Thousands of them.
yeah, right, per carrier. But
Yep.
we're starting to see our customers deploy things. They're deploying Kubernetes clusters at these locations, right?
Yep.
And they're also deploying Kubernetes clusters at the aggregate and in the core data centers.
Core data centers.
Now they have this massive problem, maybe not a problem, but a massive environment of compute resources supporting Kubernetes clusters everywhere. It just, thousands of Kubernetes clusters, tens of thousands of Kubernetes clusters. They might be 3 machines, they might be 50 machines in any given access edge environment. So this becomes a real kind of operational challenge, right, Rupak? I think that's what we're getting on the next slide. So I just wanted to expand on how big that is.
One quick question, Rupak, I guess for you maybe. What you're showing here is a telco distributed architecture in the previous slide.
Correct.
Right? Because it talks about access edges. Would that change if it's an enterprise, or is there a different distributed architecture for the enterprise, or is it similar?
So great question, Kamesh. Yeah. Depending upon the components that are being used. So remember, when you talk about telco, they have many components. As you can imagine, when you make a phone call, somebody needs to verify that you're the right user, you have the right amount of minute purchased. So there are there are a lot of systems that build on top of just the actual connection piece. And so in a telco, it can be very distributed, versus an enterprise, it may just be the components that you see at the edge that Peter was trying to explain, or the aggregated edge. So in enterprise, those would be the only components that will ship. But in telco, that it would be a lot more and highly distributed, like we're showing here.
Yeah, I think we're seeing beyond just if it was non 5G and non just an enterprise pure play. We have customers that are deploying, Kubernetes clusters across diverse environments there as well. Think retail edge, hundreds of stores, or in some cases thousands of stores, and managing Kubernetes clusters within those things, and doing things like the video surveillance and some of those same similar type of applications. So 5G might come into play there, where they might start having the connectivity. I know one of our customers has cellular access for some other things, and it's really painful for those stores, but I think 5G will change all that.
Yep, absolutely.
Okay, Rupak,
Yep.
did you talk to?
Yeah. So what we spoke in the last slide was really high level conceptual diagram of what are the different edge locations and how they come together. But let's talk about how it's actually realized. So this is one of the reference architecture that we have. As Kamesh pointed out, for enterprise, it may be completely different. But this is one where you may see a telco deploy a large kind of operational Kubernetes management system so that they can run their application. So let me start from the left side, which is where the devices are, or your connected cars are, or your connected devices are now. So, so you have those devices again connect to your radio towers, where you may have, or rather you will have some servers running, and those servers would be running your containers. Or if you are on 4G stack or on a older stack, you may also have virtual machines. But since we're talking about Kubernetes, let's focus on pods and containers. So they will have they will have those uh, containers running. Now, those machines, along with some other machines inside your local data center or the aggregate edge, will actually form a what we call as one Kubernetes cluster, where this is an independent entity. So in other words, let's say you have your RAN software running on these machines, then the control for those is going to be running inside your local data center or the aggregate edge. And it is where Kubernetes masters, so folks who are familiar with Kubernetes, this is where Kubernetes masters would live. So the state, which particular container is alive, which one is failing, what resources to give it to them, do we need to pin it to CPU number 1 or CPU 0, so on and so forth. So all that information is captured inside this cluster, which is running in this local data center. Now, that this is not the only thing. As you know, the containers have their own images, they have their own manifest around what configuration it needs, what resources it needs. All of that actually runs in this location, and all of this information is captured here. Now, this is, as Peter pointed out, this is just one of those many locations, and that location just multiplied by hundreds of thousands. So you will see hundreds and thousands of these repeated across a particular geography, like United States, and in smaller companies there will be less number, but regardless, there would be many of these running. So the local data center will have the local state, the images, the manifest, all the policies associated with running that software. And then they will have connectivity to your core data centers, where, as I mentioned, you will have, again, a very similar setup and maybe perhaps larger setups. So on the radio towers in your access or the aggregate edge, you may have, let's say, 3 nodes to 5 nodes to 10 nodes or 20 nodes running, whereas in your core data centers, you will have hundreds of servers running, which are connected to all these different edge locations. And these edge and in the core data center, you will have what we call as the management plane, a software that can control all these different locations, whether it's an aggregate or access edge, all these different locations from one central place, push all the policies, push all the policies to these different remote data centers and radio towers, and also be the place where the operations folks can say, you know what, um, I can look up what's happening on my radio tower number 1-3. What is the liveness of that particular container which is supporting that particular radio tower, or what is the performance aspects of the a particular container running. So the operations team here will have different monitoring systems like Cortex, which is one of the monitoring system, your logging systems, your alerting if something goes wrong, and obviously active probes and say, okay, yes, they are saying it's right, but they're actually running it right. So You can actually actively probe them and say, hey, how are they running right now? Now, I'm just talking about one particular center place, but in reality, that's not going to be the case. There would be many regions for a large carrier. You can imagine you have 4, 5, 6, 7, I don't know, depending upon the size of the country. There may be many more regions, and those regions would be interconnected so that any operations person can log into one of the regions and see what's going in that region, but they can also go into another region and say what's going on in that region.
Hey,
Rupak, do they have to send people on site to repair these environments, or is the trend more towards centralized management?
So I think, Peter, you're alluding to the fact that it's important that the folks here in the central location in the core data center can control and change the software. And we spoke about this flexibility because it's software. Now at container level, you can just change one particular. You can just control and change one particular service amongst the thousands of services that you're running at this location. So if your bug is found, there is a security problem that is found, you're able to go and change just one just by sitting in your central location.
Hey, Rupak. There are some really relevant questions that I think we should answer now.
Sure.
One of them has to do with the hybrid cloud scenario, right? Now, here you're describing a core data center, which is obviously on premises, and the edge locations, by definition, are at the edge, right?
Yep.
What about a hybrid cloud scenario? What if somebody wants to use a public cloud for the core data center? Would any of this change?
So that would be an addition to this architecture, and in hindsight, we should have added that. So think about a link from the management plane to one of or many clouds, and that would this is how a hybrid scenario would work. In fact, this is very real. Even telcos are looking at running some of the components in cloud where important. So a hybrid is at this point of time almost given. Peter, you were about to say something.
Oh no, I think you're right. What I'm thinking is for these radio tower locations, we're in the data centers that they're remote data centers they're connecting to would probably have a direct connect to a cloud, an AWS environment where they're running the core data center applications. So instead of this section over here being on-prem, it's more of the core data center portions, and that might be distributed across, east and west and things like that. And then another location.
So that brings up actually another question that just came up. And if the worker nodes, as you show here, are running in remote locations like radio towers, and the masters are running in this example in a local data center, how do you handle the latency issues across the masters and the workers? That's one part of the question. Another part of the question is these masters themselves are distributed because they're in different data centers or even in public clouds. So how do you handle latency, and how do you handle this distribution management of these distributed masters?
I can take that. So remember, these masters are not distributed. They are in one location. The workers may or may not be remote. And even if they're remote, the latencies between those is not that much. Typically, we have seen the distance between the workers and the masters to be few kilometers, and they are connected by dark fiber. So for all practical purposes, they are essentially in one location. They are just distributed in a small geographic location, but from a networking perspective, they are essentially within, I would say, few milliseconds.
Rupak, I think we also have other architectures where some of the masters are running it with the cell phone towers, with that local cluster, and then other clusters running in the local data center. Yep. So it just depends on how that specific customer is implementing it. Would that be right?
Yep. And we actually had many deployment diagrams, but just to summarize, we just presented this. But as Peter said, there are many ways it's possible. This is just one of them.
Yeah.
Just to follow up on the masters, right? So you said there's only one set of masters in one of these local data centers. Is that correct?
That is correct.
And there are other local data centers too
Yes,
with
there will be
masters running
many.
there.
Yeah.
So
Correct.
is
There
there
will be
some
many.
sort of a federation between these, or how do you manage these distributed masters and control planes, if you will?
So this is where a great question, Kamesh. This is where a management plane comes into picture. So as with Platform 9, we have one place where you can see all your clusters, all your masters, and using that management um, software like Platform 9, you can manage all of these different locations from one place.
I think
And you can create, you can replace. Go ahead, Peter.
no, what I was going to suggest, Rupak, is maybe we talk about that on our last slide or wrap up, where we have that slide that shows that stuff. And
Yeah, absolutely.
maybe we should jump into some of the performance related issues and why these are so important at a performance layer.
Yep. Yeah. I can get started on this, Peter, and chime in as needed. So one of the big things with 5G, and we spoke about it earlier, is really high bandwidth, low latency. And as you can imagine, one of the things that has been going on for a while, which was not present maybe about 2 years ago, was okay, how do you run these virtual functions? Well, if they are not, well, they are virtual functions, but they were running in virtual machines with technologies like SRIOV or DPDK and MAC VLAN and IP VLANs. There are a bunch of them. How do you run those? So in last few years, the industry has evolved, and now it's possible for you to have these network acceleration technologies available to your containers as well. So by default, when you use Kubernetes, you actually get only one network for each of your containers. And as you can imagine, this is pretty much useless for any networking application. You need you need at least two so that you can get the data in, process it, and get the data out. So this is where something like Multus, which gives you the ability to have multiple network cards associated with your containers or pods in Kubernetes terminology. Then we have the SRIV, which gives you multiple virtual functions on a physical networks. Intel and Mellanox are leading the band there. So they provide those functionality. The challenge is to obviously expose those to the container. Then you have other technologies which which are coming up. BGP is becoming very popular. Calico is leading the charge there. So you need, depending upon the workload, you may need that. And then if you're running in public clouds or even core data center where you may not have access to those server machines which have those specialized network cards, you may use other networking technologies for perhaps a higher latency, but still much better than traditional uh, networking technologies like flannels and others like MAC VLAN and IP VLAN. So they give you those kind of performance improvements. Now this is all great, but if you go and look at if you go and look at um, how to configure a server with, let's say, SRIV and DPDK, it's there are tons of steps you need to configure operating systems, so on and so forth. So one of those things that we have done at Platform 9 is really make it easy using what we call as Kubernetes, not what the industry term is, Kubernetes operators. So really make it very easy where you define I need these networks with these network acceleration capabilities, and then these operators can go and configure those those operating systems and those network cards with that configuration, the desired configuration that you have. And another related one is if you want to know what is the state of that particular node, what are the features of that particular node. So for example, if you have two servers, one which has SRIV cards, one which doesn't, how do you even know? So there are technologies which discovers these features of each node. You need to be able to expose those. So all of this is coming together, and that's what we have done at Platform 9, where you can not only discover the feature, you can also program it with the desired configuration.
So we can deploy an operator that will deploy a pod in a Kubernetes cluster. It'll deploy it with multiple interfaces, Calico, Multis, and maybe an SRIOV or DPDK. It will then realize the underlying hardware
Yep.
and say, oh, I need to do huge page support. I need to do, MTU settings. I need to do all the things that need to happen at an OS level. Configure that as we're deploying the Kubernetes cluster.
Yep, absolutely. And going back to the conversation that you were having earlier, Peter, it's all comes down to the flexibility that this model offers now.
Yeah,
You can just take a server, and instead of going through your scripts to configure the OS, as soon as the OS comes up, the Kubernetes can take over, and then you can really configure the whole system remotely.
and that becomes a problem, right? Your scripting and your automation for deploying some of this stuff, when you might have a set of servers with a certain set of NICs and then another set of servers with a different set of NICs.
Yep.
Right. Without consistency, then that makes a real challenge for deploying it. And the operator accounts for that, right?
Yep. And what happens is, it's not as if in one access location you will have many different kind of servers, but it's possible that you have something in Florida next to your place, which is all consistent, but something in New York, which is completely different hardware. So you're dealing with different sets in different places, and everything needs to come together. And that's where some of these automation really helps. Now let me talk about IPv6 as well. So we all know IPv6 has been coming for last 20 years now. In enterprises, the adoption is still low, but we have seen that. But on service providers who really feel the heat of lack of IPv4 addresses, most of them, if not all, are already moving to IPv6. And which means if you want to run Kubernetes in those environments, you really need to have the Kubernetes support IPv6, which means all the Kubernetes services need to support IPv6. The networks that you create, we spoke about SRIV and bunch of networking technology, all of them need to support IPv6. Your application need to support IPv6 if you're a vendor who is supplying these applications to these customers. You really need to support that. Otherwise, it would be completely incompatible in their environments, and you will not get an IPv4 address. And so really this becomes a challenge. So any distribution, and Platform9 is one of them, you'll need to support IPv6 through and throughout your whole stack, from your own app, from your own services, all the way to the containers that are running those services.
Yeah, awesome. But there's one more aspect to performance, right? Because if you're starting to process packets at line speed, you got to talk about CPUs.
Oh yes. So in addition to exposing network, so SRI is really about exposing the raw network capability all the way to your container so that it can have direct access to those network cards. But as we know, nowadays we have server machines with many cores. I'm just showing two sockets here, and many cores. You want to make sure that when you deploy your pods and who want to connect to that particular NIC, they're topology aware. So in this diagram, we are showing two NICs, two GPUs, kind of asymmetrically connected to different sockets. So the pods, which lands on CPU socket 1 should connect to the NIC or GPU, which is close to that socket, and the other way around. So it's really important for these applications. Again, we are talking about connected cars, we are talking about factory automation, we're talking about guided vehicles, we're talking about surveillance. All of these require high performance optimizations, and this is another dimension to it. So it's not only the network cards, GPU cards, but also making sure that the workload that's running on that CPU don't kick it out So there are issues with CPU caches and stuff. So you want to make sure those are running on that CPU socket on that particular core and connected to the nearest device that they're interacting with.
So we're pinning the pod to a CPU on the same NUMA boundary as the NIC. So we ensure a very fast data path to the pod to ensure the lowest possible latency for processing of that data packet.
Yep.
Yeah, that's pretty awesome stuff. Okay, should we talk a little bit about Platform 9?
Yep. So we spoke about all the different capabilities, but if you look at it as the system and the deployments, what we really need is a system which can support, and I will start at the bottom, which supports things running in your data centers, because we spoke about how core data centers are important. They are part of the large deployment. Some services would be running in your core data centers. And depending upon the customer and what environments that they may have, they may run it on physical machines, on OpenStack using KVM virtualization, or on VMware. And on the right-hand side, we obviously have public clouds. There was a question from one of the attendees about, hey, do we support, are there workloads running in public cloud? Yes, absolutely they are. And it's important for any system to support this. So that's on the other side. And we spoke about how 5G or edge location deployment is very important. There are other use cases as well. For example, CDN, media applications who require high performance computing, or who are running in not on the far edge, but they're still running on in like co-locations or very close to their customers, or retail stores which are actually running at the far edge. So a platform needs to support all of these different diverse environments, but that's not enough. You have to support that. On top of it, depending upon where your customers are, or what they are trying to do. We spoke about Kubernetes a lot. This is where the world is moving, but there are applications which won't be able to move, and they are still running on virtual machines, or they are still running on bare metal. In those cases, your system needs to support both of them. And it's important because you don't want to have multiple systems, one supporting your virtual machines and other supporting your virtualization, and third one supporting your containers. So if there is a system which brings all of them together, it brings in that efficiency. And once you're done with it, let's say you have deployed everything, then really the day two operation starts. You have to deal with upgrades. Containers are still a fast moving technology. There are bugs and patches. So you need to be able to obviously upgrade these things which are running in these remote systems, which includes the actual your own applications, but also the underlying infrastructure, be it virtualization, bare metal, or containers with Kubernetes. And then there are security aspects to it. Who has access to what? Remember, some of these systems are in remote location. They somebody may go and tamper it. So you want to make sure that you're taking adequate steps to secure them. Obviously, when you're running it in a remote location, you want to make sure that you are able to back up the data and then restore it. You may lose servers, you may to replace servers. So that becomes very important.
Rupak,
In some, yeah, go ahead.
Yeah, I was just going to jump in. If I were to sum this slide up, right, Platform 9 offers a solution that will allow you to deploy Kubernetes clusters where you're running your workloads, whether they're in the data center, at the edge, or in public clouds, right? It automates the deployment of that Kubernetes cluster. If you're deploying a 5G kind of workload, we have that networking operator that will allow you to deploy Multis and OVS and Flannel and DPDK and SRIOV at your choice, right? We have fully exposed automation around all of that, right? So if you want to do it through our API, you can. So I can now deploy a complete NFV environment wherever we need to deploy this in any environment, manage multiple Kubernetes clusters in massive massively distributed locations, right? And then from there, we bring in the observability to give you the poke into the health of that Kubernetes cluster and those applications, right? We can help you with CI/CD pipelines and ingress and service mesh and different things through our Kubernetes stuff. So it is a complete solution. And then the real beauty behind Platform9 is the day two operation. Did you want to tell them a little bit about how we really help it there?
Yeah. So if you look at, so this is what the customer sees, but this is like an iceberg. This is the features that you see, but what about the day two operations? Are these things running consistently? And if there are problems, are you able to troubleshoot them? And what are the golden signals that you need to watch for? So all that stuff is actually handled by Platform9, where we manage, you not only get these features, but we actually manage them. It's really running as a cloud service where you have to just consume it and not really look into the details of how it's running, and if it breaks, who's going to fix it, because Platform9 is there to fix it.
There's a quick question here, Rupak. There is a question about what are the best practices or the safest approaches to upgrade these services that are so distributed in different environments?
Yeah, so depending upon the service that you're talking about, and this is where something like containers and Kubernetes really shine. So the things that you upgrade may be something as small as a container or as big as, let's say, 20 containers or 50 containers. So now you have the power and the flexibility to upgrade only some of them. So that's one. The other thing is specifically with containers, and Platform9 has done some work, but even with Kubernetes, it's possible to do like a zero time upgrade where you can have multiple containers running at the same time, and you upgrade one of them while the connections are still on the other container. And once those connections die down, you can throw that away, and your newer container can take over. And with Platform9, we do the same thing at the infrastructure level. So if you want to upgrade Kubernetes, we do one host at a time, where if there are connections, if there are containers running, we make sure that they have done their job and they're idling. And once they're idle, then we remove them, upgrade that particular server, and then do it in a rolling fashion. So that's really the beauty of running with this cloud, what we call as the cloud native ecosystem.
We're coming up on time. There's just one last question. There are a few additional ones which we will answer offline, but there's one here that's interesting around using big data and I guess large data processing with Kubernetes. Are you seeing those use cases out at the edge or in the data center?
Peter, do you want to take that?
We are absolutely seeing big data use cases. I think that's a complex question on how where the data is coming from, how it's being transported, where it's stored, and how you're processing it. So I would probably suggest. I mean, I think we talked a long time on this topic. But at a high level, we are seeing those kind of things. I don't think we're doing much. I'm not seeing much. Rupak, maybe you are, of any big data processing at the edge right now. But that's happening.
Yeah. So not at the edge, but we have seen. I have seen Spark, Kafka usage definitely in the core data centers.
Okay, I think we're just about time. I do want to take a few minutes to thank everyone and also the contender for today's webinar prize. We just did a drawing internally and we have Robert Edwards at Matrix X Software as the winner of today's prize. So congratulations, Edward, Robert, if you're still on. We will catch up with you and send you your prize after the webinar. And thanks again for joining us today. Robert, Rupak and Peter, any closing comments before we wrap up the webinar?
Thanks for attending, everybody. Appreciate your time.
Yep. Thank you very much. We will
Thanks,
follow
everyone.
up with a post-webinar blog, and you will get a recap of what we covered today. Thanks again, and have a great rest of the week.